Hey Rams, now aren't we having a great time in this chapter all about areas of different shapes and sizes? So we are halfway through chapter 11. Give yourselves a round of applause, a pat on the back, and all that good stuff. Today we're going to be stepping it up a notch, a little bit more also when we go over 11.5 part B. But today we're talking about regular polygons, people. You're going to have to join us in class as we together discover the formula for how to come up with the area of this polygon. Before we talk about the specific formula for finding the area of a regular polygon, let's talk about some of the things that are going on here on this slide. Every polygon has a central angle. In other words, it starts here. The vertex is always going to be in the center. So just like a circle has a center, a regular polygon also has a center. And just like a circle has a central angle, a regular polygon does too. Now the central angle is formed by two radii. It's not just circles that have a radius. Come to find out, a regular polygon has one too. And a radius is a segment that joins the center to any vertex. I have my center here, and here's a vertex, here's a vertex. And we've got several of the vertices here around our polygon. And a radius, again, just joins the center to any vertex. Now we've got our central angle that's formed between the two radii. We have the radius that we just talked about. And the last thing here on this slide is this apothem. It's this blue segment connecting the center straight down to the base. And it's always going to create a right angle. The apothem is a special thing. It's a new word for all of us, and let's talk about more of its characteristics on the next slide. So the radius, like we said, was a segment that joins the center to any vertex. Again, it's not just circles that have a radii. Regular polygons do too. Apothem is a new word for us. It's a new concept. It's a segment that joins the center to the midpoint of any side. Some other cool things going on here. Only regular polygons have apothems. And again, what makes a polygon regular is if all of its sides are congruent and if all of its interior angles are congruent. They're the only ones that have the apothem. All apothems of a regular polygon are congruent to one another. In other words, there's several apothems that are inside of a polygon, just like there are several radii. Those apothem and those radii are all congruent to each other. Now I'm going to skip down here to the last one. The other ones we're going to talk about at length in class. The last one we're going to be using a lot. A radius of a regular polygon bisects an angle of the polygon. In other words, let's say I have the angle here of one of my polygons. The amount of sides that this polygon has is not important right now. I just want to focus on the radius and the angle. So it's saying here the radius of a regular polygon bisects an angle of the polygon. If this is the center of my polygon, this would be my apothem. And it's saying that the radius, I'll draw it here in black, bisects this angle. So wouldn't it be great to know what that full angle was? And then we could discover what half of it would be inside of our newly created triangle from half of the base, from our apothem, and from our radius. And it's always going to be a right triangle. Let's keep that in mind. This, ladies and gentlemen, is the area of a regular polygon that we will be discovering in class based on our second slide. The area equals 1/2 of our apothem, so capital A would be representing area, lowercase a is representing the length of our apothem, and capital P is the perimeter of our polygon. So the way to find the area again is we take 1/2 times the quantity of our apothem, which is this line here, times our perimeter, which would be this entire perimeter of our polygon. It's a really cool way that we're going to come up with the y of this. So again, area equals 1/2 of our apothem times our perimeter. Okay, let's use this now. Example 1. Find the area of a regular polygon below. I don't have that much information. I just know that one side is 6. Now, a great key word is that this is a regular polygon. In other words, all of these sides are congruent. And I'm going to write up here the area formula. 1/2 apothem times perimeter. Ladies and gentlemen, do I know the perimeter? Please say yes. The perimeter is going to be 6 times 6, because I've got 6 sides, and so the perimeter is 36. So now I know what I'm going to be plugging in here. The next thing I need to work on is my apothem. Let's figure this out now. So let's figure out what the measure of each angle is, because remember I was saying that the radius bisects our angle. So I'm going to have my radius there. I'm going to draw in my apothem here also. And I'm going to remind myself that this segment here is 3, because an apothem bisects that opposite side there. Okay, my goal now is to come up with this apothem. But it would be great if I knew this angle here. Now, reach back in your brains and let's remember that each interior angle of a polygon equals the number of sides minus 2 times 180 over the number of sides. I know you guys remember this from earlier. So the number of sides in this polygon is 6. So if I want to find the measure of each interior angle, this is the formula that I will use, over 6. And as I simplify this, I'll have 4 times 180 divided by 6. And then I'll simplify it a little bit more, and I'll figure out that each interior angle is 120 degrees. So what? If this is 120, I know each one here will be 60, 60. Ladies and gentlemen, I have my 30, 60, 90 triangle again. Now if I know that this bottom length here is 3, please tell me the long leg. You're right, it's 3 root 3. I know my apothem, and I could plug it in my formula. Let's do that over here. Area equals 1/2 my apothem times my perimeter. And as I simplify this, I would get 54 root 3 units squared for my area. Now I know you're not comfortable with finding it with just the root 3 in there, so you're more than welcome to approximate with the decimal value. Thanks, guys. Next one, find the apothem of a square with area of 576. Now they're not asking me to find the area, they're asking me to find the apothem of this square. Now it's telling me the area, which I know is side times side, equals 576. If that's the case, then let me take the square root of both sides to find out what one side is, and the square root of 576 is 24. Therefore the length of each side is 24. Now they're asking me to find the apothem, and the apothem is the center down to my base. If this is at the center and this is at the bottom, I know that my apothem is 12 because the whole length is 24 and the apothem starts at my center. So great, apothem lowercase a equals 12 meters. Next is saying, what's the radius of the same square? The radius connects the vertex to the center. If this is 12 and this is 12, I know it's a 45, 45, 90 because it's in a square, and that leads me to believe my hypotenuse then is going to be 12 root 2. Based on the 45, 45, 90, my hypotenuse of the triangle, which is the radius of my square, is 12 root 2 meters. Find the area of a square with radius 8. Now I know when we think of the word radius, we automatically think of circles, but we're changing it up a bit here, folks. We're changing it up. This is saying find the area of a square with radius 8. The radius, again, joins my center to any vertex. And to find the area, it's side times side. Let's figure this out. This is x, and this is x, because it's a square. Now, I could use Pythagorean theorem and go x squared plus x squared equals 8 squared. and 2x squared equals 64. And now I will have x squared equals 32. Take the square root of both sides, and I will have x equals the root of 32. 32 is 16 times 2, and I will have 4 root 2 as what half of this side is. Ladies and gentlemen, it's half of that side. If that's 4 root 2, this will also be 4 root 2, and that gives me my side will be 8 root 2. Again, when I found this length of my triangle, it's half of the base of my square, and that's why I added it to 4 times root 2, and I got 8 root 2 as a side. 8 root 2 is my other side as well. So let's do area of a square is base times height, and I have 8 root 2 times 8 root 2, which gives me 64 times 2. And that gives me, ladies and gentlemen, 128. Awesome. We're on a roll. Find the area of an equilateral triangle with a radius of 6 inches. Again, there's the word radius when I'm talking about triangles instead of circles. Yes, a triangle has a radius. Remember, the definition of a radius is it connects the center to any vertex. It's saying that this radius is 6, and my goal is to find the area. Okay, I'm also going to draw in my apothem. Now, I know if it's equilateral, each angle is 60, and this radius bisected the angle, and so now I have 30 degrees here and a 60-degree angle here. Now my apothem will be 3 because it's 30, 60, 90, and the long leg would be 3 root 3. Now I can do 1/2 base times height. However, let's go ahead and use my area formula. Area equals 1/2 times the apothem times my perimeter. Now I already know area. I have my apothem, which is 3. Now I need to find my perimeter over here. Let's figure this out. This length is 3 root 3. This length is also 3 root 3 because all apothem bisect the opposite sides, which gives me these full lengths being 6 root 3. If each length is 6 root 3, my perimeter then will be 3 times 6 root 3, which gives me 18 root 3 for my perimeter. I'm going to plug that in here now. Area equals 1/2 3 times 18 root 3. And as I simplify that, I get 27 root 3 inches squared. And you know I'm fine leaving it like this in exact form, and you're more than welcome to approximate by putting that into your decimal. One more to go, people. Find the area of an equilateral triangle with apothem 4. Let's draw this puppy. Equilateral triangle, apothem 4. Find the area. Now, to use the area formula of 1/2 apothem times perimeter, I need to figure out my perimeter. So let's see. If my apothem is 4, again I'm going to have my 30, 60, 90 triangle because it's an equilateral triangle. If my apothem is 4, automatically it's easy to write in our hypotenuse being 8, but this here will be 4 root 3. The apothem bisects, and so this is 4 root 3, which means each side is 8 root 3. Perimeter equals 3 times the length of each of my sides, which is 8 root 3, and it gives me 24 root 3. I have everything I need now. I have my apothem and I have my perimeter. So let's plug it into our area formula. 1/2 apothem, which is 4, they gave it to me, times my perimeter, which is 24 root 3. Again, I found my perimeter by using the 30, 60, 90 triangle, coming up with the leg of this triangle, multiplying it by 2, and finding the entire length, which is 8 root 3, and multiplying 8 root 3 by 3. And let's keep simplifying this, and I get 48 root 3 units squared for my area. And again, my people, you could approximate it in decimal form. I appreciate you watching this video. Now I want you to work on this homework assignment, but we're going to be doing it together in class tomorrow. Since Keystones are going on, I don't want you to have any homework, so this will be done in class tomorrow. Let's not forget though what's coming up on Friday, our partner quiz. We'll be taking it together. You could pick your partners this week, and we'll be going over sections 11.1 to 11.5. Happy day, people. Happy day.